As we begin Chapter 5, what we're looking at are trigonometric identities. So we are using our trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, and trying to mix that together with algebra and figuring out if I have an expression written in trig identities, how can I make it simpler? So there are lots of identities that you actually already know. These are the reciprocal and the quotient identities. So for example, we know that the sine of theta is equal to 1 over the cosecant of theta, and vice versa. We know that the cosecant of theta is equal to 1 over the sine of theta. So these we've already learned when we learned what cosecant, secant, and cotangent were. We also found out in Chapter 4 that the tangent of theta is equal to the sine over the cosine, and since cotangent is the reciprocal of that, cotangent is equal to cosine over sine. So these are reciprocal and quotient identities that we'll use. We also have what are called Pythagorean identities. So if we go back to the idea of our unit circle, we know that we have a squared plus b squared is equal to c squared, the Pythagorean theorem. So leg squared plus leg squared is equal to the hypotenuse squared. If we're looking at the unit circle then, we know that c, which is the hypotenuse, is also the radius of the circle, which is equal to 1. And we know that the a value over here is the height, which would be the y-coordinate, and then we have this distance here of b would be the x-coordinate. So what we know then is that a is equal to y squared, b is equal to x squared, and c is equal to 1 squared. And since this is the unit circle, we already know that the y-coordinate represents the sine of the angle, and the x-coordinate represents the cosine of the angle. So sine squared plus cosine squared is equal to 1 squared. Therefore, we have what's called the Pythagorean identity, which is sine squared of theta plus cosine squared of theta is equal to 1. We can also rewrite this Pythagorean identity in terms of tangent and cotangent. So taking a look here, if I again start with sine squared plus cosine squared, theta equals to 1. Then if I divide everything by the cosine of theta squared, we'll have the sine of theta squared over the cosine of theta squared. Cosine of theta squared over cosine of theta squared equals 1 over the cosine of theta squared. And we know that sine over cosine is tangent, so this first piece would turn into tangent squared. Cosine over cosine would just become 1. And then we know that 1 over the cosine is secant, so this last piece becomes secant squared. We can do the same thing by dividing by sine instead. So if we divide by sine, the first piece turns into 1. Cosine over sine is cotangent, and 1 over sine is cosecant. We can also look at what are called cofunction identities. So with cofunction identities, what we know is in this top triangle, we know that the sine of an angle is equal to the opposite of the hypotenuse. So in this case, if this were my angle theta, it would be the opposite A over the hypotenuse, which is C. If we then take a look at the cosine of its opposite angle here, so we know that these two angles add up to 90 degrees. So the cosine of 90 minus theta is equal to the adjacent over the hypotenuse, which is also A over C. So you can see these two are the exact same thing. So what happens then is that the sine of an angle is equal to the cosine of 90 minus that angle, or you could say pi over 2. So these cofunction identities work for sine and cosine both ways, tangent and cotangent, and also for secant and cosecant. We also know that our functions can be even or odd. We know that the sine function, cosecant, tangent, and cotangent are all odd functions. So if we take a look then, the sine of a negative angle is equal to the negative of the sine of the angle. So for example, if I had the sine of, say, negative 90 degrees, well, the sine of negative 90 degrees is equal to a negative 1. That should be equal to the negative sine of 90 degrees, and we know that the sine of 90 degrees is a positive 1, so that would be then negative 1 as well. If we're looking at cosine or secant, we know that those are even functions. So here, the cosine of a negative angle is just equal to the cosine of the positive version of the angle. So again, if I take the cosine of, say, negative 180 degrees, that's equal to a negative 1. and the cosine of positive 180 degrees is also equal to -1. So we can look at even and odd. So all together, these are all the different trigonometric identities, the basic trig identities that we will use when solving these types of problems. So it would be good for you to have a printout of this sheet and keep it for your reference. So here are some strategies that we can try when solving. So our goal is going to be to rewrite the expression that we're given as one term or in terms of only sine or cosine. This is not always possible, but that's what we're going to try to do. So always keep in mind our goal. Our goal is to rewrite the expression we're given as one term. So things that we can do is we can try changing everything into sine and cosine. It's all about substitution. Everything that we're doing now is about substitution. What does one thing equal? What does it equal to something else? If possible, we want to try to make everything either sine or cosine. So instead of just making everything sine and cosine, just make it one or the other if possible. Sometimes that helps. Give fractions a common denominator and combine them. So again, we're trying to get everything down to one term, so we would need to combine terms together. Get rid of complex fractions. So if you have a fraction over a fraction, get rid of the complex fractions. And last but not least, don't be afraid to start over. Sometimes you're going to make a substitution that just makes things more complicated, but it's okay. You can try again, start from the beginning again. Sometimes if you make a different substitution, you'll get to the answer faster. Sometimes you'll have a really long solution and the person next to you might have a really short solution, but it's the same thing. So just don't be afraid to make mistakes. Don't be afraid to start over. So here we go. Let's take a look at what this looks like. So again, our goal is to condense this expression into just one trig function. That's what we want to do. So the first thing that I'm going to try is just changing everything to sine and cosine, because we know, based on our reciprocal and quotient properties, that everything can be changed into sine and cosine. So for example, my cosecant here, if I look at my chart, cosecant is equal to 1 over sine. So I'm going to rewrite this piece as 1 over the sine of theta. I'm going to use a couple different colors just to get us started here. Secant, if we look at our chart again, is 1 over cosine. So I'm going to rewrite the secant as 1 over the cosine of theta minus, and then cotangent. So if we again look at your cotangent, we know that cotangent is cosine over sine. So I'm going to rewrite cotangent as cosine of theta over the sine of theta. So that's just changing everything into sine and cosine only. So at this point, we're going to put things together. So here I have two fractions multiplied together. Remember that when you're multiplying fractions, you multiply the tops, multiply the bottoms, numerators, denominators. So we would have 1 over sine of theta, cosine of theta, minus cosine of theta over sine of theta. So these are two different fractions being added or subtracted together, in this case subtraction. So we need a common denominator. So we have sine here times cosine. Here we just have the sine of theta. So in order to make these a common denominator, we would have to multiply both numerator and denominator by the cosine of theta. So we end up with 1 over the sine of theta, cosine of theta, minus cosine times cosine is kind of like x times x, so it becomes x squared. So in this case, it's cosine times cosine, so we would write that as cosine squared of theta over sine of theta, cosine of theta. So now we have a common denominator. So remember, we're going to put the numerators together. 1 minus cosine squared of theta all over the sine of theta times the cosine of theta. So at this point, we've finally combined everything together into one fraction, but we're still not there yet. Again, our goal is to make this one term, maybe just cosine or just sine or maybe just tangent, one thing. So if I take a look at the numerator, anytime that I see a 1 and a plus or minus and then one of the trig functions squared, right away I'm thinking Pythagorean identity. So if I take a look at the Pythagorean identities, I see sine squared of theta plus cosine squared of theta is equal to 1. But that's not what this is. This says 1 minus cosine squared of theta. So if I subtract the cosine squared of theta from both sides, this cancels, and I end up with the sine squared of theta is equal to 1 minus cosine squared of theta. Remember, this is about substitution. I see 1 minus cosine squared of theta is equal to sine squared, and I have 1 minus cosine squared of theta. So I'm going to substitute the 1 minus cosine squared of theta with that sine squared theta. So sine squared of theta over sine of theta cosine of theta. That's the substitution that I'm talking about. Sometimes we have to take these Pythagorean identities, move them around a little bit in order to get our substitution. So at this point, now we just need to reduce the fraction. So I have essentially, so let's do a little sidebar here. This is like saying x squared over x times y. I can cancel one of the x's and be left with an x in the numerator and then have a y in the denominator. That's what we're going to do over here. I have sine squared over sine, so one of those will cancel, and I'm left with the sine of theta over the cosine of theta. And so last but not least, sine over cosine we know is equal to tangent. And that is one trig function. That's our goal, to turn something that started off like this and say that this is equal to just the tangent of theta. So this is my answer. So let's look at another one. So think about what we need to do first. Our goal is to combine it all into one. The first thing that we're going to try is rewriting everything just as sines and cosines. It's generally the first place we start. So secant, look at your chart. Secant is equal to what? Well, it's equal to 1 over the cosine. So I'm going to replace that. And this time it says x, so we'll go ahead and write x's. It doesn't matter. Then we have tangent of x times sine of x. Okay, so tangent of x I can write as the sine over the cosine. So sine of x over cosine of x times the sine. And I'm going to go ahead and write sine of x over 1 because I can see that I'm going to have to multiply fractions. So again, we're going to go ahead and combine these things together. So I have 1 over the cosine of x minus sine of x times sine of x is sine squared x over cosine of x. Notice I already have a common denominator. So I'm going to go ahead and combine these two together and have 1 minus sine squared of x all over a cosine of x. Remember, only combine the numerators, not the denominators, because we're adding fractions. So you have to remember all those fraction rules. So I see a 1 and I see a minus sine squared. So again, my brain is thinking, look at those Pythagorean identities. So I know that sine squared of x, and again, on your chart it says theta, x theta, same difference. So here, I want it to look like 1 minus the sine. So if I were to subtract the sine over here, I would have cosine squared of x equals 1 minus the sine squared of x. So that is my substitution. So 1 minus sine squared of x turns into cosine squared of x over cosine of x. Again, this is like having x squared over x. I can cancel it. So this is just equal to a cosine of x. So that's my answer. Okay, we're going to keep looking at more examples. So taking a look here, why don't you go ahead and give it a try on your own first. Look at your chart, see what you can substitute and replace and simplify. And then if you're stuck, come back and take a look at the solution, or if you think you've got it, come back and see if you have it correct. All right, so let's go ahead and take a look at how I'd work this out. So I see a sine squared x and a cosine of x, but my eyes are really drawn to the sign of pi over 2 minus x. So I can see that that's a cofunction identity. So I might start by just trying to eliminate that. So let's see, sine of pi over 2 minus x, let's see, what would that be equal to? That's the same thing as cosine. So, okay, that's cosine of x. So I can do that. I could replace sine squared, so let's go back to that Pythagorean identity again. So sine squared of x plus cosine squared of x is equal to 1. So if I take a look at this, I could say that sine squared of x is equal to 1 minus cosine squared of x. I could do that. So if I did that, I'm going to end up with some kind of quadratic, because I would have 1 minus cosine squared of x times the cosine of x minus cosine of x, and I have to multiply this. But I think I see another option, which is I could factor out the cosine. So the cosine of x times, and if I'm factoring that out, I would end up with sine squared of x minus 1. And if I look up here, if I were to subtract 1 to the other side, I would get negative cosine squared of x, right? So I could replace it there, or I could work through it this way. I feel like this is going to be an easier solution. Not that this is incorrect, but I just feel like this is simpler. So the cosine of x, sine squared of x minus 1, okay, that would be negative, and don't forget the negative, that is important, cosine squared of x, and if I have cosine times cosine squared, that's going to be a negative cosine cubed of x. Now let's see if we came over here. Let's suppose we didn't factor that out. What if we went ahead on with this substitution? So I would end up with the cosine of x minus cosine cubed of x, and then minus cosine of x. And I see that cosine of x minus cosine of x would cancel each other, and I get minus cosine cubed of x. Notice I get the same thing. So some of you might have thought to replace this sine squared of x first with this. Some of you might have seen, well, let's factor out the cosine of x. Both of these are correct solutions. We get to the same identity. So they're both right. They're just two different ways to approach the problem. So this is something that you'll see a lot of times with solving these trig identities, is that there's multiple ways to get to the correct answer. So sometimes we see let's factor first. Sometimes we do a little bit of substitution and multiply, and we get the same answer. Neither one of these was really longer than the others. Sometimes that will happen. It just depends on what we're working with. Okay, so let's look at some more examples. Again, this is helpful. More practice, you'll get better at it. So go ahead and take a moment to try this one on your own first. Go ahead, pause the video, and come back, and we'll see how you did. All right, so taking a look again, hopefully you noticed again that there is a cofunction identity running around here. So cosecant of pi over 2 minus x, if I take a look, I see that cosecant of pi over 2 minus x, or minus theta, is equal to secant of theta. So this would be negative secant of x minus tangent squared of x secant of x. Now, in this one, we could change everything into sine and cosine, but what I kind of notice is if I look at my Pythagorean identities, there's a Pythagorean identity that already has tangent and secant in it. So this looks a lot like the last problem that we just did. I could factor out a negative secant of x, and that here would leave me with a 1, and over here that would leave me with a positive tangent squared of x. And then if I look at this 1 plus tangent squared and I look at my chart, I can see that that's equal to secant squared. So I have negative secant of x times secant squared of x. So that's negative secant cubed of x. So you don't have to always change everything into sine and cosine. That's just a strategy that we use. So it's perfectly okay to leave things as tangents and secants or cotangents and cosecants as long as it makes sense. Sometimes we want to change everything to sine and cosine. Sometimes there's a faster solution by not changing it into sine and cosine. Okay, take a look at this example. So it's getting a little bit more complicated. We have two different fractions. So let's see what we can do with this. So again, just go ahead and give it a try on your own. See if you can combine those two fractions together, getting a common denominator, and then come back and see how you did. All right, so thinking through this one, I can see that I have two different fractions. So the first thing I'm going to try is just to get a common denominator. So over here I have 1 minus the sine of x, and over here I have cosine of x. So what I see is that I would have to multiply over here by 1 minus sine of x, both numerator and denominator, remember. And then for this fraction, I would have to multiply by the cosine of x. So let's take the left side first. So cosine of x times the sine of x times the cosine of x would be the sine of x times the cosine squared of x all over, and I'm just going to go ahead and leave it in its factored form for right now. You can factor it out or you can distribute it if you want. You don't have to. We may or may not need to do that. Over here, I have 1 plus sine of x, 1 minus, so just don't forget to FOIL. That's the key here. So 1 times 1 is 1. I would have minus sine of x plus sine of x, so that cancels. And then I would have negative sine squared of x. Again, denominator cosine of x, 1 minus sine of x. So putting these two together, remember we subtract the numerators, so it'd be sine of x, cosine squared of x. Now don't forget to distribute that negative here. So it'd be minus 1 plus sine squared of x all over cosine of x, 1 minus the sine of x. So just take a moment, take a look at what we have here. So we have a minus 1, I've got a sine cosine x. So what can we do with this? I'm thinking something to do with the Pythagorean identity, so I'm just going to write it over here. So sine squared of x plus cosine squared of x is equal to 1. So what could I do? I could substitute sine squared of x with 1 minus the cosine squared. So that's a possibility. I also have a cosine squared right here. I could replace that with 1 minus sine squared and turn everything into sine. So that's another option. So which one should we do? It actually doesn't matter because remember, we're not afraid to make a mistake. So at this point, I feel pretty confident. So let's see, which one should we do? Sine or cosine? Sine or cosine? I think I'm going to go with the sine. Go ahead and replace that sine squared. So sine squared of x is equal to 1 minus cosine squared of x. So let's see, what would that turn into? I would have the sine of x times the cosine squared of x, still the minus 1, plus 1 minus cosine squared of x, all over cosine of x times 1 minus sine of x. So what happens in the numerator now is these 1's will actually cancel. So let's just go ahead and rewrite it, take another look. So I have sine of x, cosine squared of x, and then minus cosine squared of x, all over cosine of x times 1 minus sine of x. So now I just have two terms, and I can see I have cosine squared in both of them. So let's go ahead and factor that out. So cosine squared of x times then the sine of x minus 1 all over cosine of x times 1 minus sine of x. Aha. Now, see how these two look very similar, but they're backwards. So we're going to go ahead and factor out a negative, and if I take a negative out of here, that's going to turn that negative, that negative, that positive, and see that now these two match. It's 1 minus the sine of x. So those two will cancel. I've got cosine squared over cosine, so one of those will cancel. And then I'm left with negative cosine of x. Now, just for our purposes here, let's suppose we went the other route. Let's suppose that instead of changing out the sine squared, let's say we changed out the cosine squared here. So what would that do? How would that make the problem different? So we'd have the sine of x times cosine squared, which would be 1 minus the sine squared of x. We would still have the minus 1 and plus sine squared of x. And that would be all over cosine of x times 1 minus the sine of x. So here, I would have to FOIL this out. So I would have the sine of x minus sine cubed of x minus 1 plus the sine squared of x all over cosine of x times 1 minus the sine of x. Already, to me, this is looking a lot more complicated. So we can see that we have the sine cubed, and we could try to factor this out. So let's see, how would we factor this? Maybe put the sine cubed and the sine squared together, so we could factor by grouping. So minus sine cubed of x plus sine squared of x. Get some more room. And let's see, then we would have plus the sine of x minus 1. So I'm putting sine cubed with sine squared, and then the minus 1 and the sine of x together. So factor by grouping. All over cosine of x still, and 1 minus the sine of x. So here, I can't factor anything out, but over here, I could factor out a negative sine squared. And I would be left with sine of x minus 1 plus sine of x minus 1. Any more room? So cosine of x times 1 minus sine of x was my parenthesis. So now, we're factoring by grouping. So factor out the sine of x minus 1 times, and it would be negative sine squared of x plus 1 all over cosine of x 1 minus sine of x. Again, these two, we had them over here, right? If I factor out a negative, that's going to fix my signs. So now that would cancel. Still need more room. So I have negative times what's left over here. So I'm going to go ahead and multiply that out. So that would be sine squared of x minus 1 now all over cosine of x. And we see that sine squared of x minus 1, remember sine squared of x minus 1 is negative cosine squared of x. So negative cosine squared of x over the cosine of x. And again, that would reduce to minus cosine of x. So we got the same thing again. I got negative cosine of x here, negative cosine of x here. Notice that it took me a lot fewer steps when I replaced the cosine, or the sine squared on the end with the 1 minus cosine. by replacing the cosine squared, it took me a lot more work, a lot more algebra and factoring. Doesn't make this answer wrong. It just was a different way to get the same answer. So, if I had seen this first, replacing the sine squared first, then I would come to this conclusion. And if I decided to replace the cosine squared, I would come up with this solution, which, again, is a lot more detail, a lot longer. But either way, the answer to this question is negative cosine of x.